All right, I wanted to make a video. I haven't posted anything in a couple of weeks, and I wanted to make a video what's going on here a little bit. I've got a job to do these, I guess these are called, they're kind of like the front strut for a plane or something, or some kind of aircraft. Here's the parts. This is the setup piece off the lathe. I guess they had it come out of the chuck or something. This is an end plug in it. I don't know, they had a problem with this first part, so this is the setup piece here. Here's an old one that had, I don't know, it had some kind of quality issue a long time ago, and it has the machine work done on this one, whereas you can see, well, if I put them both the same direction, like this, you can kind of get an idea here. There's where the forging, this is a forging, by the way, an aluminum forging, and it's been turned in the lathe, so I'm getting it already turned in the lathe, and then I have to do the milling work, which is some milling here that looks like this on this boss, the little hole, I don't know if you can see that right there, and a tapped hole here, and then this boss here gets milled away, 2 holes in a round boss on it, and up here on this end, this gets drilled and bored, and there's a little pinhole on either side of it here, and I think there's a little bit of something in the bore there, a couple of kind of radius key slot like things. So this is the part I'm going to set up here, and here's the actual run of parts right here on these pallets. This is the parts I got to do for this job. I think there's 27 of them altogether to do. I'm getting some tooling ready here for this. This lathe work is kind of, I don't know if you can see. Well, this isn't the best one to look at, probably. Over here might be better. So these are the good parts. And the bore, this part was solid when they first got it, and they had to bore it all out. And this particular bore on this end has to be held to 1/1000th of an inch tolerance all the way down, and a 32 finish. These areas on the OD get turned, and this boss area, it's going to get milled away into that round boss here, but they've roughed out some of it. So these were solid forgings when they started, all of these. So I got to machine them. And we'll go over look at the solid model a little bit and discuss about certain machining operations and what's got to be done. I'm looking at a piece of special tooling for this job, maybe, because I have to do some machining on the back side, and I'm kind of looking at this. Let me see if I can find this is their brochure-like thing. I downloaded off the internet, off their website. And this particular boring head, or not boring head, angle head, is coolant driven by high pressure coolant. So let me see if here's a drawing kind of the system. I wouldn't have that cat taper shank on it. Either get it a capto shank or a straight shank, and I'd put it in a end mill holder. So we're going to see. I don't know. This is kind of an expensive piece of tooling, so I'm not sure yet. Kind of getting some prices and availability on it, but we'll kind of look at the model I've cobbled up on the computer. This particular job didn't come with or the customer didn't have a model, and so I had to make one myself on this. Anyway, let me kind of take a screenshot of the computer, and you can see this model I drew up. I didn't make it in detail on certain operations that are on the lathe operations because I'm not doing them, and so it's not really necessary for me to do that. So let me go to the screenshot, and we'll discuss about the machine work and what needs to be done. And also, while we're out here, I've got to bore these jaws. Now, this is the plug that goes in the end of the part, which is just a hair smaller than the diameter of the part. Now, you see with regular soft jaws, like let me get one here, you run into this issue. Like here's one of the jaws I used on my previous job. So you can see if I use regular soft jaws for this, the jaw's about 1.5 inches thick, I guess. And this is going to end up being bored out this large, so you're going to be intersecting the holes in the chuck jaws. And if the jaws are only like this wide, you're going to only be gripping with just a very small area because these jaws go all the way back, and I can't hit the screws, of course. And I could only buy this particular set of jaws also in this height, and I'm going to have to face about this much off the jaws too. But in order to get a better gripping area on the part, I felt it was necessary to go to the pie jaws to do this. Otherwise, I'd only be grabbing with just this little section on each side of this screw hole, because the bore is going to intersect the screw holes, if that makes any sense. So, unfortunately, although, you know, it's not really too expensive, these jaws aren't that bad, so for this job, it's going to be fine. I don't want it to be slipping out of the chuck or something when I'm milling. Now, some of the milling is going to be done with the tailstock in, and then I'm going to put this, my homemade steady rest. I've got to modify some jaw tips on it, but we're going to mount this steady rest here. Or I might be able to use these jaw ends, I have to see, but I have to bore them for the size of the part. And that's going to be running on this diameter of the part. The lathe guys have left this oversized. I think 20 thousandths, I think they said. This is a very close tolerance with a good finish, so we can't afford to scratch it up with a steady rest or anything. But I have to run the steady rest in order to do the notches in the, you can see it on this one, those notches in the bore, and be able to reach down to get those holes. The hole in that boss and the hole in this boss with these long tools and the boring heads. And I'll have a drill in this longer collet chuck to do that. So the rest of it, I'm hoping on this operation is pretty much straightforward. Just mill it in there with the B-axis tilted at I think it's a 7-degree angle. But this is where the difficulty on this part comes in, is doing these spot faces. It's a very close tolerance on the width, the thickness, if you will, between the front and back spot face, 1/1000th of an inch tolerance on both of them. And they get these little holes on the front and the back. Now, the front side wouldn't be that difficult. You could reach it with a long tool. But the back side, if I have my part mounted in here like this, how do I get to the back side spot faces on here? That's kind of a problem. And so I'm looking at that angle head that's coolant driven. And if I get that, I think I can do both sides of the spot face and both of the little holes on each side with it. But we're going to see on that. If not, I got to do it a different way. Sort of got a plan on that if I can't get the angle head thing for some reason. So let's go to the computer here and discuss the part and the setup. All right, here we are in my CAD software, and this is the part I modeled up. There was no model provided by the customer in this case,
So I had to model this up. This is an old part, and what they're basically doing, I think, is the parts are no longer manufactured by the manufacturer of the original airplane, and so these are kind of like aftermarket parts, I believe. At least that's my understanding. So in order to keep these planes running, we've got to have these replacement parts for them, or we don't, but the people making this do. And as you saw earlier in the video, I showed you the forgings and what the lathe work is all done here. If we oh, well, I didn't draw the lathe work accurately, so I'm not going to show you that because it's not really my part to do. That was all done already for me. But let me turn on the stock. So this is my stock definition, which is kind of what the parts look like right now. I didn't model in a lot of detail here because it's not necessary for what I'm doing. All I'm worried about is the actual machining features. And this is the stock as best I could approximate it from the first operations on the lathe. And I have to mill away to what you see, the darker model, to where the stock is right now. Now, the sort of tricky part of this part, as I talked about before, is it's actually going to be facing, let me see, no, it's going to be facing this direction on the lathe. So this end's going to be in the chuck, and this end's going to be out towards the tailstock. The way I've drawn it here, and my 0 point's going to be right on the end of the part as you see it there to do the machine work. And I have to reach all the way from here to do these features. Now, you saw the boring heads and stuff. I got to do these two bores here. They're a very close tolerance, like less than 1,000th of an inch tolerance on these two bores. So I'm setting up boring heads to do that. And you saw the tools I showed you, and that wouldn't be so bad. But so I can drill that from the end with that long collet chuck and drill. It clears the diameters here and everything, but and the boring heads clear everything. But the doing these spot faces and milling this stock away around this boss, all of this stuff, the outside's no problem because I can do that from straight down, like with surfacing cuts maybe, and I could even go around this boss to some degree that way. But to do these spot faces all the way from the end of the part, well, that wouldn't be too difficult. This relief has to also be milled in here. And even these little holes on this one end wouldn't be that difficult, but to come back from the other side, there's really no way. Even if I flip the part around in the chuck, and ran a steady rest out here somewhere, that would be possible, but this distance, see, let's just actually measure that. So there is 15 inches, and the distance from here to this one is 21 inches, almost 22 inches. So that's not really practical to reach all the way down there to do that. Even with a piloted spot face thing, I wouldn't want to do that because it might mar up the bore, and there's a very close tolerance. So the other way would be to, and which was done in the past. This is the first time I've done these parts. They've been done by some other people before here in the shop, and they used an angle head on the bridge mill, I believe. They came in here and milled this with an angle head from the back side. But this distance from here to here has to be held within 1,000th of an inch, and the depths of the counterbores have to be held within plus or minus 2,000ths of an inch of being the same as each other, which is odd, but that's the tolerances. So the depth of that has to be virtually the same as that within 2,000ths, but the thickness itself has to be held within 1,000th of an inch. So that's a little bit tricky to do, reaching all the way down from the end of the part. So that's, and then these little holes, this hole lines up with this hole on both sides, as well as the same thing on this. And how to get that hole in there from the back side too is kind of in a way problematic. And I want to be able to do it all. I could do all this in one setup. The only thing that's going to, other than that, that's going to be kind of an issue is this one hole here, which is in the chuck jaws. And I'm thinking I can mill a notch in my chuck jaws to get my tools in there. It's a 1032 tapped hole, I believe, if I remember right. And so I can get this part complete in one setup. If I can rig up that angle head, that Kulik driven angle head is actually most ideal for the Mazak Unigrex because I can orient and clamp the spindle as if it's a lathe tool every 15 degrees. So I could come in this side and mill these counterbores with a little end mill. And then actually this is the model of the Kulik. Well, I've got various different configurations here. Let's this might be the way it works with a Capto end mill holder with a straight shank, or I was thinking if I could get a Capto shank on the thing, and then it could be this much shorter. I can move this part of the boring head, or I want to call this a boring head because it looks that way, the angle head, and clamp it here, and it reduces the length 2.5 inches, I believe. Let's see. Yeah, 2.5 inches shorter. So that might be a way to go. Anyway, I need to. This particular angle head has a ER16 spindle nose. So I think what I'll do is make special little tool holders, if you will, with an ER16 taper, and it has a thread on it, so you just kind of thread it in there, and it makes up on the ER16 taper, or you can put a collet in there, and they have a special nut that goes on there. But if I put everything in a collet, then I've got to touch the tools off every time I run the setup on every tool. And what I want to do is actually run an end mill and mill this counterbore on both sides of these two bosses, so I can come in this direction and then mill that counterbores on this face and then index 180 and come in this way. And basically I just got to adjust the offsets till I get my dimensions. And then I could change to a spot drill and spot these two holes on either side of each one. And then the drills and drill. They're two different sizes, actually. They're not both the same size. They're this size on 3/32, I think, on this size, and a little bit under a 16th, or maybe it's the other way around. And this looks like this is the 3/32 one, and it's a little under a 16th on this one. So it's going to take an end mill, spot drill, a drill, two different drills. So that's 4 tools. And I thought maybe if this works real good, I can profile around this boss and cut this radius with a ball end mill. So we're talking about 5 tools. I'd have to change out every time in that 90-degree head, and it would be better if I can just make little ER16 tool holders, if you will. They're small tools. They'd be, the end mill probably be a 1/4 inch end mill and maybe a 1/4 inch ball end mill to profile around this boss and surface this radius. This is a 3/16 radius here, and come down here a little bit if necessary. I think I can mill some of this from the side, and I can of course profile all around the top of this ear, if you will, with some kind of surfacing cuts with a ball nose end mill if I work fine there. Rough it off and then surface it with maybe even a 5-axis move would be nice there. This relief can be cut from the end of the part with a longer end mill. This is left as forged, and of course this all can be, like I said earlier, done by tipping the B-axis back 7 degrees beyond 90, in this case 97 degrees, and milling all this in and putting these holes and the round boss in the middle. So that's the part that I have to do, and there's also these 1032 holes on either end, and these little key slots that go through the thread for some reason. Not sure what that does. So that's the part. I just wanted to go through this little explanation of my idea of the setup. These are 1/4 20 holes right here as well, and show you that because I hadn't really posted anything in a while and I've been busy with stuff. And we're going to get into the actual machine work and everything of this part as it goes, but first I got to determine that angle head thing. Not having that, I got to do this in a different way, and it involves back spot facing tools, which is not my favorite way to go here. The one kind is where you put the arbor, the tool, through the hole, and then you manually put the tool on the spot on the arbor, and then you feed back in this direction, like to cut the back spot face. Then you feed back and take the end of the tool off and go out, wrap it out. That kind of is an iffy way to do it on a CNC machine because if you forget anything, you've had a drastic accident, and I'm not really wild about that, as well as those tools tend to chatter unless they fit really nice onto the shank, and then might even have to make bushings for the bore. And to put these holes in, lacking an angle head like arrangement, I thought about making a drilling fixture that lines up on this hole, and I could drill from the back. So that's another way to do it if I can't, get that angle, that coolant fed angle head thing for some reason. So anyway, this is just a little quick video, or maybe not that quick a video, but a little video showing the plan and the setup. And the next video will be on actually doing some of this machine work. So thanks for watching.